So if it has to like get this be sure that that's 80. Now they are brighter. Hey guys. Just gonna unmute my microphone so you can hear what I say. Welcome to another episode of Designing the Propeller. Please let me know if you think my background music is too loud or you can't hear my voice or anything. I got the chat open. So last week we did a lot of the designing of this this piece right here. We did the cone in the middle to begin with, and we did some playing around with the fins. the fins actually turned out to be a bit harder to do than I actually thought it would be, but and I wasn't too happy about the result, but I actually went ahead and did a few tweakings when we went off camera. I am going to show you something from, this is a screenshot from last week's live stream, and as you can see, the thing I was not very happy about is the fact that the fins went underneath each other, which they don't at all do on the original. So that was kind of a pain. But since then, I actually tried to redo the loft function and made it look like, can we reach this one? Oh, if I did this. And now it actually looks like this. So now they have some room. I don't know if it has any usable result when it gets into the water, but this is the piece as we left it last week. I would also like to be able to do these fin edges more sharp, because I think that would of course be better, that they would look like a real aeroplane blade. But there's an issue with this. If we have to 3D print it, we have to make sure that there is actually enough material to make a layer that size. So to begin with, I'm trying to make it like this, where it has this rounded edge, and then we can always do some more tweaking and see if we can make the fins a bit more like real fins. But yeah, this is the propeller as it is right now, and I'm thinking we are going to go ahead and well, we could try to have some fun with the loft function. It's actually not that bad of an idea to show you how it works. Remember, when you use Fusion, you can always go back to your timeline here in the bottom and find the function you wanna edit or completely remove. I only made one loft, so that's pretty easy. This is the one. I'm gonna edit that, and it's gonna move the timeline back to where we were at that point. And we can do all kinds of crazy things with this fin. And when we have finished doing stuff to this fin, we can just say OK, and it will reapply it to all three fins and do everything we told it to do afterwards. So we should be golden on that front. There is two edges here I can move and do stuff with, and pull them in and out to my liking. This was actually the way I did the way I made it not go underneath each other. Let's try just to say an OK on this one, just for fun. Let's see if there's still room. And again, I don't know, I'm not an engineer, I don't know if it has any usable result either way, but I actually think this propeller looks pretty good. So what I was thinking was that maybe we should try to just keep the fins here and go back and try to do the fins in a more, see if I can show you, a more yeah, well, this is a real aeroplane kind of fin, but on both sides. And I'm not sure that it's gonna work like this, but we're gonna try this, that's for sure. Okay, so we need, obviously, I hope you can see this, we need a hole to secure it to the mounting rod, and We have our trusty calipers. Just gonna see what size hole we need here. 12 millimeter, and there is a hole more in there in the bottom. Let's see if I can reach it, and it's about 6. Okay, so first we are going to choose the face where we can do the drawing of the hole. I'm gonna make another sketch. I am going to press C for circle, and let's make this 12 millimeter. Yeah. Okay. I'm gonna highlight it, press E for extrude, and it's of course going to be going inside the propeller. Let's see. It's like this. It's also 12 millimeters inside, so minus 12. There you have it. We now have a new face down here we can draw on. And of course we need again a hole, C for circle, and we are going to make it, if the rod that we are mounting it on is 6 millimeters, I know for a fact that when you 3D print you have to accommodate for some wiggle room and stuff like that. So I'm gonna make it 6.25. That usually is enough. And I'm going again highlight the circle, E for extrude, and this time I am going to use not distance but to object and anchor it to this bottom piece right here, so that in case we make this piece longer, it will still make the whole way through. Okay, so that was the first easy hole to make, and the propeller also has this. I don't know if I have enough to show you this, but it has some weird kind of things inside it too. And it has this cross section, which I believe has to come from what holds the propeller to the shaft, so that it will rotate and not just have the shaft rotate inside it. So we are definitely needing to build this, to draw this piece right here in the middle. So let's just do that. I am not a major fan of making all this in the middle. There is of course saved a lot of plastic here, but it's not always a good idea when you print stuff to not have a big fat surface to print it on. So I think I'm gonna try to get around this by just making the cross section here and just pulling it down enough so it will fit the same size as this. So let's see, we can draw on this side again, and we need again to measure this piece right here, 48 millimeter. Okay, now I need to make this a rectangle. I'll use my toolbox, S for toolbox. Choose the center rectangle because I want a rectangle to go from the middle part right here. And I know that it's 48 millimeters wide. I'm gonna make sure if we can fit it. So we're gonna give it a little bit more. And the width is 5 millimeter. Okay. Tap 5 millimeter. So this should be enough. So I'm gonna make sure that the hole is actually a lot bigger. I wonder if it has to be that all the way through. Perhaps we can make that. We can make that. I know we can. Let's just extrude these two pieces down to the size we need here. Again, 12 millimeters, 12.4. E for extrude, minus 12.4, like that. We got this little thing made. And I realized, of course, that it's rounded in the bottom, but that's not a real issue because we can just make a fillet down in the bottom there. But before I do that, I will actually like to make another sketch. I think I'm gonna make the hole here in the back bigger because it looks like it has the same size hole as it has in the front, and just kind of a spacing in the middle or some way down there. Let's see if it's 12 millimeter. It is. So we are going to make it 12.25. Let's do that. Okay. We want, of course, to take everything here so we have the entire circle highlighted. E for extrude, and this is actually another fun part about this project. Oh, sorry, this program. I am not absolutely sure how long there is to this part minus this spacing we need, but I can again do a 2 object, go to this. It will of course remove everything. Then I can go to offset and say, well, I'm not able to like measure this piece right here with the caliper, but it looks like it's between 2 and 3 millimeters, closer to 2, I think. So my offset could be 2, and of course it's -2, and then we can say okay, and there we have it. Yeah, this is the way it's made. I haven't seen the rod we are going to mount this on. I don't think that originally this is not a good idea, but let's see. Okay, I want to round these two pieces because they are rounded. I don't know if you can see that, but they are rounded here in the bottom here. Let's see if I can get it to zoom in on this. I think I can. No. Work on some more lighting down here. But I am going to make it like if it was just rounded all the way. F for fillet. These two. And I think I remember that we made this rectangle was, as I recall, 5 millimeters. That means that 2.5 should make it round exactly, which it also appears to be. Okay, there you go. We have a rounded piece right there. And apart from the hole that goes in the side, the two sides of the propeller, that's actually pretty close to being finished with the first prototype of this bad boy. The holes are in the same direction as the cross section here, and I need to know where they are, and I need to know how to best draw this. Of course, I'm not able to make a sketch on a rounded surface. That way I can't just go ahead and do sketch on this. I actually think, what would it do? I can, but what would it do? It would just tell me to go ahead, pick a place to do it. You can't do it on a rounded surface, you know that. So let's just do like this. Okay. Again, we do a little measuring. See if we can find the middle of this hole. 45.5. Oh, this also has a threading in there. Yeah, we're gonna make that. We're gonna do that with a tap later on. Okay, let's remove the body to better be able to see. I'm gonna do a line. I'm gonna do it like a construction line. It's called construction line. 45.5, like this, and a circle. And I want this circle to be a real circle, not a construction line. Let's again measure the hole. So this would appear to be a 4mm threaded hole. So if we want to thread this, we want to make sure that there is enough plastic to make a thread. So we are going to make it 3.75. It's my best guess. And the hole is going all the way through, which means that we can do another fun feature when we do an extrude of this. If I can get it, come on, yeah, there it is. Extrude, and I am just going to drag it out. No, oh, sorry. Like that. Going to drag it out like that. Okay, but I want to go both ways, and if we look here, we can see that we have, from the origin, the middle of the propeller, we have only gone one way out, and we are going to use, we can either use two sides, but this time we will be using symmetric because it has to be symmetric. Now we have just made another body, but we want to make this a tool to drill. So we're going to open this, and as you can see, everything goes red, which indicates that it's going to cut through the model itself. So let's just apply this. Okay, we have a hole in the middle there. I wonder if I'm going to be having trouble with these holes later on. It shouldn't happen. We are going again to be making a sketch because we need they are kind of sunken down between or to make the screws disappear in the holes, of course, and we need to insert them a bit. 4mm. Wow, the measurements really go again and again and again. I am going to make a sketch on the middle part of the propeller again. This time I'm using Project P. I'm going to choose this hole to get something to help me. Remove this, turn it left. And I didn't get the other way measurement. I'll make it 10mm. C for circle, which it doesn't allow me to do here. That's kind of odd. Construction line. Construction. Oh, I was lucky there. 10mm like this. Okay. But if I open my drawing and just take this out, I'm going to make the hole destroy the propeller. That's of course not the idea with this. So I am going to have it start not at profile plane but an offset, And again, I am going to guess this because I can't really get to figure out where this hole starts. So it's going to be a bit of a trial and error. Start by 10,000. Yeah. 10. Okay. Yeah, I'm definitely going to run into some troubles with the propeller, I think. Let's see if we can remove the propeller a bit. We could perhaps do that. I guess the offset is, again, I'm going to choose symmetric because I'm not going to use symmetric because apparently a symmetric can't do the offset. And why can't it do that? That's weird. It has to do that 2 sides instead. Okay, I'm going to make it all the way through, and okay. I'm not going to use 2 sides, I'm just going to use 1 side, and then I'm going to mirror the feature afterwards. Okay. Really annoyed about this because there's really only one way to do this unless I start over with the fins. Let's see how bad it goes. Pull this one a bit. This. And the offset 15 millimeter. Ooh, I think that's good. Okay, so we definitely got a hole there. Now another fun feature, which I also use a lot to make things easier. S and mirror. And instead of mirroring a face, I'm going to mirror a feature. I just made a feature which was this extrude. I'm gonna highlight that. It asks me to select the plane. I'm going to select this plane, and hopefully it will do kind of the same thing here. It's not 100% certain because they don't look the same. But let's try see what happens. Yeah, it worked, but it doesn't always work. But this time it worked. Okay. Something tells me that I am able to make this crossbar sit in another direction if I need to, but I'm not sure that moving this that way and that hole the other way will make any help to us at all. So I'm gonna think about what I'm gonna do here, and how on earth did the fins get so different from the original, one could ask. We are still running, yeah. It's gonna say I'm gonna run out of, that's for you, those of you looking at Instagram, I'm also over on YouTube, where you can see my screens and stuff like that. Yeah, let's try to just say that this was the first version of the propeller. I'm really not happy with this part right here. But on the other hand, I am not entirely sure what to do about it, I must admit. Let's look at the loft one more time and see if we can do something funny with it. Need to remember that it is tangent and direction. But what if we do curvature? Oh, that was the one it didn't want. Make it. That looks like. Okay, that's a crazy propeller. And one of the holes in the last part we made actually went to, I'm not gonna say it, but that part of the hole doesn't work anymore. Because now everything on this surface has changed. So yeah, let's move it back. I'm gonna regret to undo that and if this even has any issues, but I guess the propeller has to be somewhat even weighted all over the place when it turns. I am pretty sure that I need those holes no matter how I do this. Save this. I'm gonna make a copy of it. I'm trying to see if we can perhaps get a better save as copy. Okay, now we hopefully have two of these, so we're not gonna destroy all the work we did. We have, okay. I am going to actually, I'm going to go, that's all the way back. Let's scroll through the scrolling through back through the timeline to see what we did. Oh. Weird mouse today. And that's before we made fins and stuff like that. Oh, the fins there, but the fillet on the fins are gone. I really like the way this fin wave like this. I'm sure it's going to be a turbo function. Let's see. Back to where I draw this. And reapply the canvas like this and see. Okay, this was the original canvas we were using to kind of draw up where we want our piece to, our fin to work from. See if we can move this a bit. Oops. Why? Move it. Let's turn it a bit like that. And something happened, but well, something really good actually happened because we just got ourselves some room to try to rotate. I'm not entirely sure this will work, but let's try it for the fun of it. I want that marked out, I want that highlighted, and this, and this, and this, and this, and everything that should be rotated. M for move. I of course need to be sure that its its origin is in the middle. And again, I'm not absolutely sure that this will work, but let's try. Oh, it's not liking it at all. It wants to go the way I don't want it to go, which is kind of a pain. I am pretty sure if I do like this and like this, I can go ahead and do this thing. But can we then see what we want, where we want it to go? That's the problem, right? See, we want to make sure that we don't interfere like that, perhaps. And now we can simply highlight the hole, press delete, another powerful feature. Delete, yes. And we will simply just align the hole with the new crossbar section here. Let's see. Oh. If I use our original origin now, we will not be in the correct angle. If that's not a problem, just saying that sometimes you need to think about these things. I'm going in my construction menu and I'm going to find something called a midplane. You will be using this a lot. I'm going to make me a plane to draw on in the middle, but perpendicular to the new crossbar section. And we are then, thank you, to highlight the new plane we made. I'm gonna do a sketch on it, and we need to make the holes again, but this time I think we are going to be better off not interfering with the fins. So let's try to turn off the body, make a line, construction line from, no, that's not the bottom of the piece, is it? No, it's not. I'm going to do a project of the bottom of this right here. Yeah. Oh yeah, that's finish sketch, because I need to reapply the sketch, edit sketch, so that it is perpendicular to me. And body off, construction line, farthest away. And if I remember correctly, it was 45.5. Yes, it was. And we want a hole of that was a 4mm hole with the threading, 3.75, and you wanna make this go all the way through. Symmetric. Let's go. It's still not ideal, but it's not ideal on this either, I think. Oh, it's kind of the same now. Let's keep it like this. Okay. Now I have something down here it doesn't like. Compute failed. Okay. What if I delete it? Nothing bad comes from that, right? Nope, it's okay. I just made a plane that way in the right orientation, which makes it unnecessary to make another one, because you can really on big designs you can have like hundreds of these planes, and then when you have to use one of them, you are going to scroll down and down, unless you are one of the crazy people who always rename your planes as soon as they are made. I'm sure someone does that, not me. Okay, let's draw a sketch. We already have something we could use as a projection. The holes we are going to make bigger, like this. And since I don't have the right angle, and it's not like I can do like this, because we have kind of made that option not very friendly for us anymore, we are going to say finish sketch, and as soon as we've done that, we are going to edit the sketch, which will then center it for us. Again, we have a circle tool, which again, of course, doesn't want to work here, I think. Nope. I could use the offset tool, but to be honest, it's too late for me to start doing math about how much more I need to do. So I'm gonna try to see if I can make another one. It has to be somewhere in the middle. Well, it doesn't want to do that. It's really weird. See if we can like this. This is pure luck if this helps. It's close enough. 10mm, as I recall, yeah, 10, 5. We have made this circle inside this part right here. And again, we want it to have an offset before it starts, so it doesn't destroy the inner part of the fins. Like this. E for an extrude. And we want it to go all the way. Cannot complete extrusion. Why? Something about that red part in the middle, I think. Does this sometime. Delete that part. Extrude this one. Much better. Much better. Okay. Okay. Well, obviously we don't want that big of a hole all the way through. Again, we are going to do some very good guessing. Offset, let's just call it 15, I believe was correct before. Still looks good. Yeah, it's not so bad. Now we should be able to do the mirror feature function. So let's try to do that. S-M-I-R-R, mirror. Feature, the last known extrusion we made, and we want to do it on our plane from before, of course. This one. And it kind of does a bit of an outline there. I'm not entirely sure it's going to work, but well, there you have it. It worked. And let's just see if we can do something about this. This doesn't have to be a problem. Now, do some more fillings there. Fillet. Go, 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 go. Yeah. Okay. That. And really want to make one on this one also. I can hear my graphic card roaring up. There was a problem, don't say. If you run into problems with fillets, sometimes just trying a smaller number will help you a lot. Usually it's not a lot smaller you need to do it. 1.5 would be also, yes. And we want a fillet in here to make it stronger. Now this part right here is the part where you go through your model, and if you try to design something and 3D print it, you will eventually learn where you have to make your model stronger. And a fillet from time to time, or a lot of times, works immensely good on that. Okay, I have one thing to tell you about this piece right here. If I am going to print this like this, I would be best off printing it from this side against the bed, and I could of course just rely on my slicer to do the support material for these fins. But I think that I would be perhaps better off if I did some kind of cool break-off support right here in the sketch, in the drawing. I'm gonna try to do that. Just gonna make sure that we have everything important on the model. Yeah, it would seem so. So take from this side. Now I am not able to project. Yeah, I am. Okay, that's weird. This one. Yeah. This one. Wow. Okay. Now I actually have something to help us. Okay. And we need to make an offset of this. 4 millimeter, I guess. and the other way, -4mm. Let's do that with just the one, and right, I'm just gonna make one. I'm gonna use this amazing tool called, yeah, what is it called? Pattern, of course, right? Circular pattern. Now, let's see. Make this like go all the way up. I'll make a new body, please. I'll make a bed for it to land on, like that. But if you do that, it's gonna be fused together. No, it's not, because we're gonna do another cool feature right after we make this. What the? Yeah, and there. Okay. Extrude, and I'm gonna make a new body, and I want it to go to this part right here. Now, if I don't tell it to do a new body, it will automatically think that I want to cut out this piece. So I'm gonna make a new body like this and say okay. That way I have not fused anything together yet. And now I am going to use this, our propeller, as a tool to remove whatever is inside this piece of support material, he said, hoping that it would work. I'm going to use the combine tool. My target is where I want the thing to be cut out of, which is my support material. And my tool is, of course, my propeller. And I don't want it to join, I want it to cut. But if I do this, it will cut and remove the propeller. I, of course, want to keep my tools when it's done, like that. If I now remove the propeller, you will see that it has a fine part of the propeller inside this piece right here. To save on some filament, I can make a fillet here, like this. That's really just for fun. And a very, very powerful tool is the tool called offset face, which I also use a lot. You will get to know it if you try to make like, let me see if I have one. If you try to make stuff like 3D printed threads and stuff like that. If you do them and not offset the faces, you won't be able to move anything. They would just be stuck in most cases. So I am going to offset this face. Again, I'm going to use S, and oh, great. I'm just gonna highlight all these again. Give me a minute. Like that. S, offset, and it's right there, offset face. Now, I just want to make sure that when I print this, it doesn't fuse together, which again can be trial and error. My guess would be 0.4. And of course I want it to go minus, I want it to go away from the part. Like that. It cannot be, okay. 2, perhaps. Wow, that's annoying. 1. It can do a 1. 1.5. 7.5. We are negotiating now, the machinery. Okay, let's just say that we can live with that. There is also the possibility to simply remove a bit more later on. But for now, let's try to make this work and try to put it in the slicer and see what happens when we try to make a 3D printing file for this. But before that, I would honestly say that I don't need this to be that big, like that. And if I can just take this one and say S offset face minus 0.15 again, like that. Okay, so perhaps the thing I did wrong there was trying to have it calculate too many faces, and instead of just having one face calculated and it just pulls the other with it. It could be the thing. Okay, now another tool I want to show you is the tool called Inspection, which has a lot of great ways to see if your different bodies and components are touching each other. And in case you don't want that, you need, of course, to do something about that. I'm trying the interference tool right now. Let's just choose two bodies here. I've selected two, as you can see here. I'm going to do a compute, and it's going to tell me, well, there are no interference detected because we made the offset face to accompany for any differences in that area. Okay, we are also able to do an inspection tool called section analysis. And section analysis also needs a plane to start on. So if we do like this, we can see a cross section of the propeller. What I want to see right now is actually to make sure that if I haven't done the interference, I would like to be sure that my piece right here wasn't interfering. And printing wise, I have already found a stupid thing we need to remove, because this is the top of the propeller, this triangle right here. It won't be useful at all to print something on top of this. It won't support anything. So we are going to remove that as soon as we just see that it floats very nicely along the edge without ever touching. It's like magic. Wow. Okay, but the other thing there, that is you can save these center analysis and just do like when you want to view and unview bodies and components, but I usually just turn them off when I don't need them anymore, or just don't accept them as pieces. Okay, so this triangle is the part on top right here. A lot of ways we could remove this. I'm thinking something of a cut down the middle. I really want this base to be as big as possible to make sure that it has a good adhesion to the bed. We could try to make a fillet on this and see what it does. But then again, I really want the bottom part to be as one. Doesn't help either, so let's not do that. Let's just do the old kind of cut. I'm gonna do a sketch, and I want something up there to be gone. Let's see. Let's just make a line like there to there. Let's go back because that was stupid. Just gonna make a line somewhere there and there. And I want this triangle gone like that. But I don't really mind the fact that it's in the bottom here. So let's again do an offset. Here we could actually also use an object and say we want it to start here, like that. That was, that was the other way around. Okay. Just pretend I didn't do that. Why is it not visible? Great, great, great. I'll go back to my sketches again. I'm able to see them. Now that I look at this, I think there is an even easier way to do this. I can actually just move this, and whenever you have a face selected, you can always select where you want it to pivot from. If you go over here to the move copy tool right here, choose set pivot and choose where you want it to have a new origin from. And when you've set it, you need to go back and like apply it, you could say. And now we should be able to just do like this. No, of course it won't do that. Oh, you are so annoying today. Okay. I do construction, and I want to be able to just gonna remove the propeller. I want it to construct it from this side. Now we have 3 planes, and we only have actually it's only a little sketch we are working on. Yeah. Did I get it like that? Sketch, yeah. Project this, yes. Okay. We want L line. Let's go. On this top. Okay. Extrude, and we want it to go to where it doesn't help us anymore. I don't think that's enough. Pull it a bit further down, halfway there. Okay. Now if I look at my body here from the top, I now have but this is still not very usable because again we are going to make something go inside the propeller, which doesn't make any sense. So let's just go back, and instead of doing this line right here, we are going to make another one all the way down here. And we are going to extrude. And this time I'm going to do the fast way. I'm just going to move it like this. And I can actually just choose this one and let it go a bit further down like that. Remind you, this is just a piece to be thrown out afterwards, so it's just to help us. I hate when that happens. Some little bit of the body is still attached to just do it the correct way. Make an offset of this like this. Okay. I'll make an offset of this like this. Okay. Thank you. Is there anything in there? Nope. Not gonna work either because I need to make sure that this one is tied off and this one. Let's remove everything here. Highlight what I want to be gone. E for extrude. Pull it down. See it cut. The lines are on. It's just this a bit further down without destroying the bottom, of course. Great, it's almost art we are making here. Okay, so this is the support material. I'm just gonna keep it this satin steel color so we can see the difference. Now we of course want 3 of these, and we are going to go to create, and we need a pattern, and this time of course we need a circular pattern like when we make the fins. The object is a body, and the body is this one. The axis is of course the center axis, and that's what we are going to find right here. And by default it always makes 3. And if we make like this, look at that. We just made our own support material. That might even work. We are not gonna not have support material, because in here we are going to have support material, of course, because that angle, just turn it a bit like that. That angle right there is too much for your 3D printer unless you print it in on an SLS printer or something like that, which would not be a bad idea actually. The only problem is I don't know anyone who has one or can help me in that department, but perhaps someday. I'm only 3 live streams in, so perhaps someday I will actually eventually own an SLS printer. That would be cool. A mess, really mess, but really cool also. Now I am going to hopefully be able to make an STL file out of this. And when I say hopefully, I mean that my my Fusion program has actually been in a habit of dying on me the last couple of weeks when I tried to do that. Okay, I am just quickly going to go back to before I made the pattern, because I can see that we still have something that goes like in over the propeller, which is not necessary at all. So let's see if we can. Actually, perhaps we should use a chamfer. There it is. You will actually notice that sometimes when you have trouble using chamfers, fillets, in my opinion, is the most easy option. And on this part in particular, it doesn't really matter because it's just a support material. So like that, and we are going to again save our propeller boat, and let's just we have No, we don't, but let's just do like this again. And now we have 3 support materials, which is 4 bodies in total. We could of course make these into components, but I don't see the need for that right now, as long as I'm able to make an STL file. I'm going to make an STL file of everything so that I'm sure that I will also have an STL that has the support material. So on top of this tree over here, save as STL. Let's see what it does. So far so good. It makes a mesh of the propeller. Looks pretty cool. Yeah, I'm just gonna say okay to that. And let's just put it on the desktop. Like that. And it didn't break at all. Okay, now I am going to go straight into my slicing software. And we are going to use the Datsun Fusion i3, the yellow one behind me, because that one has a big nozzle, which is great for bigger models and first-time prototypes. So yeah, let's just get to our desktop, and this is the one. It's a big model. Okay. So this is the STL file inside Simplify 3D. My slicer of choice, mostly because I bought and paid for it. But no, it's actually, I think it's a good slicer. Okay, I'm just gonna make sure that my process settings are... We are of course gonna do a prototype in PLA, just to make sure that the measurements are okay. And then we will later either be doing it in ASA, perhaps ABS, I'm not sure that's gonna work, but ASA or some kind of freakishly strong nylon or something like that. But for starters, we are going to go with just making a fast prototype. Layer height 0.4. That's gonna be a low resolution print. Let's just layer height 0.4. Okay. Prepare to print. I don't even know, it doesn't have support added right now, but what I really want to see is actually that my support materials doesn't fuse together with the propeller. So let's just go down. As you can see, we also need some infill. Let's just make sure that we have, because a 0.4 nozzle is actually a kind of a 0.6 nozzle. It's kind of a big nozzle. But actually this could give some drooping, these long lines going out and in again, but I am pretty sure that this propeller won't be used before having some kind of finish anyway. So 3 hours and 16 minutes, which I guess will be more about 3 hours and 40 minutes. It's not that accurate, unfortunately. But this is our propeller, how it looks in the slicer. I think that we are definitely going to need some, well, we need some support material, and we also need some infill, because infill helps us with the inside holes there. Let's just do a 20% infill, and let's just say that we want our support pillar to be 3.5 max overhang angle. I would say that anywhere from 45 to 60 should be okay. The lower the number, the more support material or the less angle it will try to hang over. 45, generate, there we go. And now I believe that we are going to be closer to 5 hours of print. I'm just guessing. So I'm gonna have, oh, well, that was not correct. 8 hours of print. Wow. 8 hours of print. Eight hours of print with a very, very, very low quality resolution, which I'm just thinking ahead and say if we want to do this in a high resolution, it would be like 20 hours per propeller, I guess, which I am pretty sure won't be very good payment wise, or not payment wise, but and the amount of time and the possibility of a print failing halfway. Too much risk there. So we need to think a bit out of the box with this one. Okay, first thing we can do, we can start by, our infill is what it is, but our support material doesn't have to be 35% percentage, it could be just 20. The support base layer, I like that because it gives extra stability. Let's try see if we change something there. Please go below 6. Oh, 6. 6 is about my, I can live with that. 6 hours is not like too bad if it fails, but still it's annoying as hell. And I really don't think that these homemade support pillars are that expensive print-wise, so I don't think we could gain that much by just removing them and let the original, but of course we can try. It's actually pretty simple. But other than that, I think that it might work. It might work. Yeah. Obviously, I'm not gonna start this print and just have you hanging here on the live stream. That would be pretty stupid. And I can see we are an hour and 15 minutes into the live stream, so I am actually thinking that this is what we are going to do today. This is where I leave you. I hope you have had fun. If you like this video, remember to give me a like and just go ahead and smash that thumbs up button. And of course, if you are not already subscribed, it would be a good idea because this propeller is not done. We haven't printed it yet, and one of the next couple of days I am going to hook the yellow. This is really, really difficult. I'm going to hook this yellow printer up with some filament, and we're going to try to make a prototype of this. And as soon as the prototype is done, I'm going to give this to my friend and see if it fits on his boat. If it fits, we are going to go ahead and find some crazy ass filament to make it with. So this is me, Eastmount 3D, saying goodbye and thank you. I'm going to go going to bed. Have a nice day where you are. Nice night if you are a place where, like me, it's actually nighttime now. Yeah. See you next time. Bye.